Hello again. Today we're doing a question from section 1.5. This is question number 8 in 1.5. So again, yours might have different numbers, but it should be the same kind of idea. So I want to talk about, this is about average rate of change. Okay, average rate of change. Now, the book teaches average rate of change like it's something new, and it's a little frustrating for me. Average rate of change is not really a new thing. This is the same thing as slope. Okay, let me repeat that. Average rate of change is the same thing as slope. Okay, those are similar concepts. The reason this is called average rate of change is because we're not talking about a line. In this case, this is an x squared equation. That means whatever this is looks like a parabola. Okay, and I'm not really graphing it, I'm just doing kind of a rough idea. It's some kind of parabola, okay? And so you can't really say you're finding the slope of a parabola because the slope is changing all the time. You have negative slope, you have zero slope, you have positive slope. So you're not really saying, oh, I'm finding the slope of the parabola, because the slope is always changing. But what we are doing is finding the average rate of change. So like the average slope from x equals 7 to x equals 9. So if you think about somewhere out here is 7 and here is 9. So we're finding the slope from this point to this point. So we're pretending that has a straight line. Okay, that's the idea for average rate of change, is we're finding the slope between two particular points, even though those points aren't necessarily on a straight line. Here they're on a parabola. So the deal is, since it is slope, we're still going to use the slope formula. But the issue here is the problem only gave us x values. All we have here is x1 and x2. They didn't give us the y values that we need. So that's why the book writes it this way. Okay, instead of writing the y values, they write this. Remember, that just means plug in x2 into the function. Plug in x1 into the function. So that's the same thing. These formulas mean the same thing. Okay, so this is how the book writes it for average rate of change, but it really is the same thing. We're just having to find the y values. Instead of the problem giving us the y values with the x values, we have to actually find the y values ourselves. So over here, kind of off to the side, I'm going to find the y values that go with 7 and 9. Okay, so if x equals 7, I'm using my equation here. Okay, f of 7 would be 7 squared plus 3 times 7. So 7 squared is 49 plus 21 is 70. And then for x equals 9, we're doing f of 9. So that's 9 squared plus 3 times 9. So 81 plus 27. 108. Hopefully I got that right. Let me know if I didn't. So now we really do have full points. We know one point is 7, 70. The other point is 9, 108. And we really are just finding the slope like we normally would. We just had to do a little extra work to figure out the y values. So I'm going to do my slope, or my average rate of change. Okay, so that's going to use the y value minus the y value over the x value minus the x value. So 108 minus 70 is 38. 9 minus 7 is 2. 38 divided by 2, I believe, is 19. Yeah. So my average rate of change, I really probably shouldn't write slope, I shouldn't write m. It's average rate of change. Okay? But you find it the same way, is 19. Meaning that's actually a very steep slope. Okay, you can see how large these numbers are. We're like way up here on this parabola. We're way up there. So it's got a very steep slope right up here. So a slope of 19. Okay, so I hope that is okay for everybody. Let me know if you have any questions or if you want to see anything else. Just send me an email. All right, thank you.